Hi, I'm Sarah Shank with Matrix Technologies. In this video, let's explore plant water usage and ways to reduce your water footprint within an industrial facility. If you're watching and you keep track of water consumption within a plant, or if you keep an eye on your residential water usage, you know that water is an increasingly valued commodity and regarded as a limited resource. There are two main ways to reduce your water bill. One, reduce your water consumption, and two, maximize the investment of the water you do consume. Let's focus on the first point.
To reduce your overall water consumption within a plant facility, start by tabulating all water users along your utility water header. This could be chilled water, cooling tower water, or hot water, whatever water utility you use. Starting with process and instrumentation diagrams, or P&IDs, or plan views of the system is a great start, but field verification will give the most accurate results. Here's a simplified example of a chilled water loop servicing a vessel jacket, a heat exchanger, and the seal system of a pump. Once all the users are accounted, use the equipment design data and any available vendor information to calculate the theoretical or design water usage. Compare the design flow rate with actual water consumption for each user. The actual water usage can be calculated in different ways depending on your process. If you have a continuous process with installed flow meters, use the flow meter readings in the data historian as a comparison. If your process is batch-oriented, use the equipment information to calculate the water needed for each batch and the production schedule to calculate the number of batches over a specific time period. The time period will most likely match the dates of your water bill for a direct comparison. If your process operates as a hybrid between continuous and batch, or your process is continuous and historical data is not available, portable clamp-on flow meters are available for rent or purchase to capture actual flow rates. Once the design and actual water consumption rates are tabulated, compare the two to see where the largest discrepancies are and focus water reduction efforts where they will make the biggest difference. Perhaps a leak may be identified that has gone undetected, or an adjustable globe valve may have been accidentally left open. Water reduction might also be administrative. If hose stations or sinks have higher actual rates compared to design rates, encourage employees to be water conscious when washing down equipment and turn faucets off when they are not actively needed. That last tip we can all use at work and at home. If a project is in the design phase, consider materials of construction that can tolerate lower water quality. Let's take a cooling tower water system as an example. Here is a depiction of a low cycle of concentration, or the ratio of contaminants in the recirculating water stream compared to the makeup water stream. In this schematic, the orange plus signs represent contaminants. If materials of construction are selected that can tolerate a higher cycle of concentration, the recirculating water can accumulate more contaminants, which means water will need to be bled off and replaced less often, reducing the overall water consumption. Of course, some flows are non-negotiable, like safety shower or boiler water, which brings us to the second way to reduce your water bill. Maximize the water you do consume. For example, steam condensate provides high-quality hot water to be reused within the boiler system or elsewhere in the plant. The steam was already fresh water you paid for. Reusing the condensate for another use reduces fresh water flow and reduces effluent flow, both of which have associated price tags. Other effluent flow streams from industrial facilities can also be treated on-site for reuse within the plant. Depending on the composition of the effluent streams, filtration and treatment options can be selected as additional treatment after the site wastewater treatment plant to meet quality requirements for reuse within the process or as makeup cooling tower water. This option can be explored in the design phase of a new facility or as a retrofit for an existing facility. The additional filtration comes with a capital cost, but may be worth exploring depending on the site's water usage and dependency on a single freshwater source.
Hopefully this information helps you start saving or maximizing water at your industrial facility or just at home. Matrix would be happy to help you investigate water usage and potential savings at your facility. Find out more information about Matrix using the links in the description below. Thanks for watching.